So let's do some FTIR practice. If you're brand new to FTIR, you might want to go watch a basics video before you go through this. If not, stick with us. You'll learn just fine. And I should probably actually make a FTIR basics video. Also, if you want to pause this video right now, screenshot it and work it out on your own and come back, that's great too. See if you get the right answer with us. All right. So we have this FTIR spectra here. And then we have these four possible molecules. So now remember, FTIR is qualitative, not quantitative. So it can only tell us the kind of functional groups that are there. If we have two of the same functional group, it can't generally tell us which one is which unless there are more functional groups involved. But so let's see if we can get through this. And so first off, what I like to do is you can do it one of two ways. Personally, I like to look at the FTIR first to see what I should even be looking for. But right off the bat, since we are given options, let's look at these first. So there's my pen. So we have a nitrile, right here. Oh, that's terrible handwriting. So we should be looking for that C double bond N stretch. We have ethanol right here. So we want to be looking at that big OH stretch at like 3,400. And then we have methyl acetate. I don't have enough room to write these names, but we have methyl acetate right here. I'm just going to say ester because it is an ester. That's that big, what we really want to look at. And then we have dimethylformamide, which is, for intensive purposes right here, we're going to call it an amide, even though it's a mix of an aldehyde and an amide, essentially. But it's more amide, so we're going to call this amide. It's a formamide. So this, I'm going to circle the points that you want to be worried about with these. So you'd be looking for this, you'd be looking for this carbonyl, and this carbonyl. So now that we know this, we can go look at the FTIR. And usually I start at the FTIR. So the first thing we see, we look in the hydrogen bonding region. We don't see any big broad shifts here. So we can rule out an OH or an NH. So that immediately knocks out our alcohol. We're coming over. We don't really see anything past 3,000. So we have a fully saturated molecule other than maybe a carbonyl. So that knocks out our nitrile. And then what is super indicative here is this massive C double bond O carbonyl shift. And honestly, that's the first thing I ever look for when I'm in FTIRs. I go say, is there something hydrogen bonding right here? Is there a carbonyl? Is there any points of unsaturation? And then I go from there and see if there's any other, characterization techniques at my disposal to help me figure that out, like say carbon, proton, NMR or something. So based off this right here, this big old stretch, it is one of these two molecules. Well, which one? And that's where it gets a little tricky. Because see, this is a tertiary amide. So generally, primary or secondary amide would have an H here, and we'd see a big ol' nitrogen NH stretch here because the hydrogen bond, it kind of looks like that. Sometimes you'll see people call it fangs, and we don't see that. And that's because there's no NH here. So it makes it a little tricky. So what we got to do is look at the carbonyl here. Now, it's a little hard because this isn't blown up, so this is a bit of a trickier problem. But if you remember from any of your basic videos or hopefully from in class, the position of this carbonyl stretch will change depending on what type of carbonyl it is. And that's what will really help you look at it. So if we look here, we got what, 2000s, this would be 19, 18, 17. So it's just shy of 1700, but more than half, let's call it, let's say 1685, roughly, centimeter inverse. So that right there, wrong one. So this right here, that is super indicative of an amide. And it's a little higher than normally for an amide. That's probably because it's an formamide. Amides, generally, you'll see them around 1640, 1650. This ester is going to be a little higher. It's probably going to be around 1750. Depending on what you have on the other side of that ester, it might be as high as like 1785, 1787. Sometimes it's a little bit lower. Remember, these aren't exact. It all depends on little things. That's why it's mainly qualitative. That's why I like NMR is the best thing out there. But so based off of what we know here now with the ester, I'm sorry, not the ester, the carbonyl, our answer is this amide right here, and I will circle it for you. This is our answer. Hooray! So, all right, I hope that video is helpful for you guys. I know that was a little tough, and you might be annoyed, be like, oh, why wasn't that more clear cut? And well, unfortunately, in real life, these things really aren't that clear cut. And this is a good example of how FTIR is only one tool that you should be using for structure identification. And maybe in the future, I'll make some videos that are a little tougher. We'll use multiple kinds of characterization. But overall, I hope this video is really good for you guys. If there's anything else you want to see a video on, drop it below in the comments. As always, my DMs are open. You can DM me if you have any questions, or if there's something you're struggling with in class, or there was a problem on your exam, or like a practice problem that you don't understand, send it to me. I'll make a video on how to walk you through it.